All right, now you're going to get to see some of my artistic abilities as we look at some ideas here. We want to spend this section looking and modeling some possible real-world examples where we can use some of the tools that we've been developing. One such modeling problem deals with motion, and we can thank our physics department for helping us understand some relationships with motion. The primary relationship with motion we know is that distance equals rate times time. And that's going to be the primary equation that we're going to use in solving this situation that I've created. So imagine we're on the Umpqua and I have a boat that's able to travel 8 miles per hour in still water. Well, on a particular day, I noticed that I was able to go 15 miles downstream with the current in the same amount of time it took me to return 9 miles upstream against the current. So on that particular day, I'd be curious, well, what's the rate of the current? So as I'm looking at this problem, I first need to realize it's a motion problem. The second thing I need to realize is, well, what is the problem trying to ask me? What is it that I don't know? And in this particular case, I don't know the rate of the current. So I'm going to assign that as a variable. So for example, X will equal current of the water on that particular day. So based on that, do I have enough information to proceed to try to figure out what to do? Well, I'm not sure yet, but I'm convinced it's a motion problem. So let's see if I can find out some of the information that we have. So let's set up a little bit of a table. Distance, rate, and time. We have two situations. One, we're going to go downstream, and one, we're going to go upstream. The distance that I was able to travel downstream, that was given, 15 miles. The distance I'm able to travel upstream, also given. That was 9 miles. Now the rate's not exactly given. I have to kind of figure out what the rate is. So what do you think the rate that I was traveling downstream? Well, it's probably going to be the rate of my boat plus the rate of the water is going to give me my total rate. Makes sense. I'm going to go faster downstream when I'm going with the flow of the water. Now the rate going upstream, well, it's going to be my boat fighting against the current of the water. So I found distance and I found my rate. Now what do I do with time? Well, that's where we go back and remember the equation the physics department gave us. Distance equals rate times time. I don't know time, but I know I can rewrite that equation in terms of distance and rate. So I'll look at this equation, solve that for t, and then we'll know that t equals distance divided by rate. So if I have that information, then now I can go ahead and unpack what my times are. Time is distance, 15, divided by rate. Next one, same thing, distance equals rate. Now, that's pretty much the second phase of the problem. First phase is kind of reading the problem, understanding what I have, knowing that it's a motion problem. Second part is start to figure out what are my variables, and I'm able to go ahead and assign those variables some value or some value in relationship to X. Now we're in the third part of the problem, solving the problem. Now, do you remember the time that it took me to go downstream was equal to the time that it took me to go upstream? So time downstream equals time upstream. So what do you think I'm going to do with that? Well, I now have time upstream and time downstream. Let's set those equal to each other. So I have 15 divided by 8x plus 8, or 8 plus x equals 9 over 8 minus x. And now that's a problem that we can solve. We want to go ahead and eliminate the fractions. So what's the lowest common denominator that I can use to multiply to both sides? So I need to multiply both sides by 8 plus x and 8 minus x. Doing that, that's going to clear my fractions. So I'll be left with 8 plus x over 8 plus x factors out. So I'll have an 8 minus x times 15 equals a 9 times an 8 plus x. Continuing to solve that problem, I'm sorry, I know I'm going to be in the way of working this out. So 15 times 8 is, what is that? 15 times 8, 30 times 4, 120 minus 15x equals 9 times 8, which is 72 plus 9x. Start to collect my terms. 15x plus 9x. 15 plus 9 is 24x. 72 take away 20 is 48. Divide both sides by 24. I get x equals 2. So what it looks like, it appears, is that the rate in water, or the rate of the water, the current of the water, is 2 miles per hour. So I'm able to go 10 miles an hour downstream, and upstream I'm able to go 6 miles an hour in the same amount of time to reach those destinations. So this is just an example of one of the problems that we're going to be working with. And then when we look at that, we can also use that information to kind of figure out what was the time that it took me to do that. So if x equals 2, I know my time downstream then becomes 15, I don't know where to write it out, folks, 15 divided by 10, which equals 1 1/2. And I can check that again with 2. The time upstream was 9 over 6, which also equals 1 1/2. So the time it took me to go downstream and upstream was 1 1/2 hours apiece.